All right, you don't have this slide, but just follow along with me. This represents bottom dead center. That's the lowest point in the piston stroke. Top dead center, which is the top of the stroke. And then after top dead center, which means after the compression stroke. Now, this is where this degrees of crankshaft revolution come tightly into play. Now, one of the things that takes a certain amount of time is burn. How long it takes to burn the fuel in the cylinder, how long it takes to, build the pressure in the cylinder. Now, we want maximum cylinder pressure about 7 to 12 degrees after top dead center. So that would be here, maximum combustion pressure. Now, burn time takes a certain amount of time. A richer mixture burns slower and cooler, and a hotter mixture burns slower and faster. I think I said that backwards. A richer mixture burns slower and cooler, and a leaner mixture burns hotter and faster. There you go. That's the order. Now, the faster the engine is spinning, the higher the RPM, the sooner we have to light off the mixture, especially if we're blowing in a rich mixture. We want to build power in the cylinder. A rich mixture burns slower. So that means we have to light the cylinder off much earlier before top dead center. So as the piston is moving up in the cylinder and the compression stroke, technically we're lighting it off before it reaches the top. Why? Because we want to make sure we build maximum cylinder pressure after top dead center. So as the piston is starting to move down is when we want to start pushing down really hard on it. It's kind of like riding a bicycle. You're going up a big hill, you're moving the pedal slower. You want to make sure that you're after top dead center, to push down really hard. You don't want to push down before you reach the top of the pedal travel, or else you'll be pushing it backwards. Get it? So this timing, this ignition timing is extremely critical for, building maximum power in the cylinder, and it varies and changes based on RPM and whether or not the cylinder is running rich or running lean. Does that make sense? All right. Hopefully somebody will have questions if they don't. So here's the exhaust stroke. Piston's moving back up again. The exhaust valve is open. And this is to get rid of the spent exhaust gases so that we can bring in a fresh charge for the next stroke. Now, all four of these strokes take 180 degrees of crankshaft rotation. And if you add those up, that's 2 full turns of the crankshaft. Now, the camshaft, on the other hand, only spins 1 turn for every 2 turns of the crankshaft. Get it? So the camshafts are spinning at half the speed of the crankshaft. Does that make sense? No. So what happens next? Well, the whole process starts all over. It goes intake, compression, power, exhaust. What's the next one? The next stroke on that piston is intake, compression, power, exhaust, intake, compression, power, exhaust. Anyways, so we look at cylinder arrangements. There's different types. We have 6 cylinders or 4 cylinders that are inline. Heck, back in the olden days, we had 8 and 12 cylinder inline engines. Big, huge thing, all straight and narrow. Now, we also have V-type engines. V8s, V10s, V6s. We even have flat engines as well. We have to look at engine identification and the type of induction system on these things. That's how the air gets in. So we're going to be looking at compression testing. Now, it's nice to have the firing order. Realize that the cylinders are numbered, 1 through however many cylinders there are. And there's always a number one. Number one is usually the one furthest forward on the crankshaft. Now, we don't want to get the firing order off because that'll upset the timing and the engine won't fire correctly. More on this misfires when we talk about a balance test. I got a great video. It's pretty good. A couple of different ways to do it. But what am I talking about? Well, these firing orders can vary by manufacturer. Here's one, 1, 2, 3, 4, 5, 6, 7, 8. This is how the cylinders are numbered. But, here's another one. 1 through 4 is just on one side, or 1 through 6 just in a straight line. But notice that the actual firing order, the actual firing of each cylinder, the order on this engine is 1, 5, 3, 3, 6, 2, 4. So it goes 1, 5, 3, 6, 2, 4. It bounces back and forth, and we don't want them just to be in a straight line, that would make the engine very unbalanced, and it would vibrate, we would have vibrations and stuff. Now, if you look at this one, this is 1, 3, 5, and 2, 4, 6 is my cylinder numbering. So this is opposite or different than the other one, and different manufacturers number their cylinders differently. Number one is almost always the one furthest forward on the crankshaft. There's more. And then when we remove the spark plugs, we have to be very careful if there's a wire, if there's a coil attached to it. You don't want to crack the porcelain. They're very sensitive. And I'm going to talk a little bit about spark plugs when we get out to the lab. And then when we're installing the spark plugs in the engine, we got to be very, very careful. Most heads nowadays are aluminum. That makes it very soft. I mean, think beer can. I should say pop can. The threads on the spark plug itself, those are hardened. So the spark plug is much harder than the head. If we are not careful, we will destroy the threads in the head, which that would be bad. Okay, and then 9 times out of 10, I see people tightening up the spark plug far too much. It's usually those things are like 2-finger tight. You take 2 fingers and pull on the ratchet in order to tighten the spark plug. If you're in there janking on that thing, yeah, you're probably tightening it up way too much. All right. Now, one of the critical functions is sealing the cylinder, sealing the bore up so that we've got good compression, and we fire off the mixture. We're holding in that pressure, from combustion to push the piston down as hard as we can. Anyways, we have some issues that show up, like a head gasket. Now, right on the outside of this head gasket, inside the block and inside the head, there are water passages to help pull the heat away from combustion. So if it leaks here, typically it'll leak into the cooling system. And then we get, bubbles in our cooling. The pressure goes way up in our cooling system, and literally the thing pukes all over the place. Bad head gasket leaking into the cooling system. We also get, bad rings or worn pistons. The sealing on the piston itself is bad. So what happens is the combustion pressures blow by the rings, and below the rings, that's like oil pan. The oil is below that. So we could be drawing some oil up into the cylinder and burning the oil, which in this case, it would be like blue smoke, they say. Oh, and if we're leaking, forgot. And if we're leaking coolant into the engine, which we typically would, like after you shut the car off, pressure's higher in the cooling system than it is in the piston area. So we would leak into the combustion chamber, and that would get burned. We would get white smoke. So white smoke, water. Blue smoke, generally head gasket or oil. So generally water, that would be coolant. We could also get burnt valves, bad valves. Typically, a bad valve is going to manifest itself on the exhaust valve. That's the one that's under the most strain and pressure and that lives in the harshest environment. The intake valve generally does not, although it's not uncommon that it happens. An intake valve goes bad, but 9 times out of 10, it's a bad exhaust valve. So if we're leaking combustion pressure out of the exhaust valve, where would it be coming out? Well, it'd be coming out the exhaust. If it was leaking out the intake, it would be coming out the intake. And then we also got bad rings, which I think I've showed you. I think we talked about it. Bad rings generally will leak into the oil passages, into the oil, into the crankcase. So if that's the case, then we get oil also drawn up into the combustion area, which causes, blue smoke. And that's about it. Nice. Hopefully that was good. Do you like seeing me while I talk, or would you rather not and just go to the slide? Let me know.